Good afternoon, students. Today class we are going to discuss the problems that we have left in this chapter. So, this is the last class of this chapter. Let us see what are the problems we have. The question let us see first. What they said, a circular coil of radius 8 centimeters and 20 turns is rotated about an axis passing through its vertical diameter with an angular speed of 50 radians per second in a magnetic field of magnitude 3 into 10 raised to minus 2 Tesla. Okay. Obtain the maximum and average EMF induced in the coil. If the coil forms a closed loop of resistance, how much ma? 10 ohms. Calculate the maximum value of current and average EMF induced in the coil or average power loss due to Joule's law of heating effect. Okay. Now, first let us see what they said, that a circular coil is there having n turns, is rotated with an angular speed 50 radians per second in magnetic field. So, a circular coil is rotating in the presence of magnetic field. We induce instantaneous EMF, right? Okay, first what are the things they given? Let us write what are the given things ma. First thing is what? Radius. R is equals to 8 centimeters, that is 8 into 10 raised to minus 2 meters. Next one, number of turns is 20. Angular speed, they given that angular speed as what? Omega. Omega equals to 15 radians per second, and in a magnetic field of magnitude 3 into 10 raised to minus 2 Tesla. Next, resistance is 10 ohms. Okay. So, when a coil is rotated in a magnetic field, we are changing theta. So, we are inducing EMF in terms of instantaneous EMF, right? So, in the last class only we derived the expression for AC generator, instantaneous EMF. What is that? E equals to E naught sin omega t, that is equals to what is E naught? B A N omega sin omega t. Okay. Now, theta should be maximum means what? Omega t is equals to theta is equals to 90. So, E is equals to E naught, that is equals to what ma? B A N omega, where B is magnetic field, A is area of cross section, N is number of turns, and omega is angular speed. Substituting all the values, because B is what? 3 into 10 raised to minus 2. Area, because they said that it is circular coil, pi r square. What is r? 8 into 10 raised to minus 2 whole square. Number of turns is 20. Omega is 50. Sorry. So, if you calculate this one, you get the answer as 0.6032 volts. This is what? E maximum. Okay. And they said that current maximum. So, right, what we can write here? Maximum current is what? I maximum is equals to E maximum by R. What is E maximum? Just now we derived, right? 0.6032 by resistance is 10 ohms. So, 0.06 amperes. That is enough. Now, we calculated maximum and maximum current. What about average EMF ma? We should remember that this is which current? See, we get in the previous class that AC, alternating current, means which changes its magnitude and direction after regular intervals of time. So, this is T by 4, T by 2, 3T by 4 and T. So, after completion of one cycle, the EMF is what? 0, because whatever the current that flows in positive of cycle, the same current will flow in negative of cycle. So, the average EMF over a full cycle is equals to what? 0. Okay na? Next one. Average current over a full cycle is also 0. If there is maximum current, this is maximum current in positive direction and this is maximum current in opposite direction, right? So it doesn't changes, but average EMF over a full cycle will 0. Clear? For example, they ask, but that we will get in next chapter, that for off cycle, okay, because we are getting for full cycle it is okay. For off cycle, the formula we can derive in the next class, sorry, next chapter. E average for off cycle is 2 E maximum by pi. So this is the small derivation we have. If we substitute that one, we get average EMF is equals to 0.3839 volts. This is for off cycle either positive or negative. If it is positive, plus; if it is negative, minus. So total EMF becomes what? 0. And next, there is one more question is there. What that? We calculate the maximum of current and average power induced due to power loss, right? So what is the formula? Average power is equals to E maximum into I maximum by 2. What is E maximum? This only, right? 0.6032 volts and I maximum is 0.06032 volts. So just substitute that 0.6032 into 0.060 by 2. So average power is equals to what? 0.0182 watts. So in this question they have clarified, means they given all the concepts which we learnt in this complete chapter. That is, by changing coil, how can we induce EMF, that is instantaneous EMF, we calculate maximum EMF. If it is for full cycle, 0, because how much EMF or current that induces in positive off cycle, the same current will induce in negative off cycle. So average for 0. If it is off cycle, the formula is what? 2E maximum by pi. We calculate that as 0.3839 volts. The loss of power. As we know that current is induced in a conductor or current flows through a conductor, the conductor gets heated. That is called what? Joule's law of heating effect. So this is the average power that is induced due to a coil is rotated in a presence of magnetic field. So this is also an important problem based on motional EMF. Let us see that. A rectangular loop of sides 8 centimeters and 2 centimeters with a small cut is moving out of a region of uniform magnetic field 0.3 Tesla, directed normal to the loop. What is the EMF developed across the cut if the velocity of the loop is 1 centimeter per second in a direction normal to the longer side and shorter to the loop? How long does the voltage last in each case? This is a very important problem. So you should know in each case how the EMF has been developed. Okay, ma? Right. First one. First case is what? Let us take. A uniform magnetic field. Take a rectangular loop having length 8 centimeters. This is 2 centimeters breadth and this is 8 centimeters. So first condition is what? When loop is, if the velocity of loop is when in direction normal to, when loop is moving normal to longer side. Is it right? When loop is moving normal means this is the normal, this is the velocity it is moving. Okay. Now what is the velocity here? V is equals to 1 centimeter per second. So it is moving normal to this side. So what is the length of this one? Length is equals to what, ma? 8 into 10 raised to minus 2 centimeters. Right. Next, magnetic field. How much magnetic field? They said that 0.3 Tesla. It induces EMF. Which EMF? Motional EMF, right? Is it right? Because a loop is moving in the perpendicular magnetic field, the EMF induced is called what? Motional EMF. What is B? 0.3 into L, 8 into 10 raised to minus 2, 18 raised to minus 2 meters. This is 1 into 10 raised to minus 2. 8 3s are 24, so 2.4 into 10 raised to minus 4 volts. So that is okay. Next, one more question asks that how long does the voltage last in each case? How long does it last? Because until there is change in flux only it induces EMF. That is the basic concept of this chapter. Here, when it travels up to this 2 centimeters, what happens? Because it is moving normal, this 2 centimeters, how much magnetic field it is present? If it move, for example, this is 2 centimeters. My hand is, breadth is 2 centimeters, my hand is 8. Now I am moving in magnetic field, right? This is length, okay. Now I removed. Now there is magnetic field, but there is no loop. How much distance I travel? My breadth, right? Yes. So time is equals to distance by velocity. How much time it will be there? How much distance travel? 2 centimeters by velocity is 1 centimeter per second. So how much time it will stay? Means this much voltage is induced for 2 seconds. Because when it is like this, so this is, my hand is having breadth 2 centimeters, length is 8 centimeters, assume that. Now I am moving this loop. Now magnetic field is there, but loop is not there. So there is no induced EMF. But how much time it stayed? 2 seconds. Next, the same concept. Here what they change? Here what they consider when loop is moving normal to longer side. Here, when loop is moving, normal to shorter side. So the situation how we consider here? Let's see that. This is uniform magnetic field and this is the rectangular loop what we consider having length 8 centimeters and 2 centimeters. Now normal to shorter side means this is only now. Now the loop is moving in this direction, same. What is the induced EMF? E is equals to BLV. Magnetic field is how much? 0.3 Tesla. What is the length that is moving normal to this one? 2 centimeters. So we should consider here B into breadth into velocity, 2 into 10 raised to minus 2. Velocity 1 into 10 raised to minus 2, right? So 0.3 into 2, 0.6 into 10 raised to minus 4 volts. Okay, in the same way, now how much time it will stay? Now I am moving my hand like this. So it has to travel how much distance? 8 centimeters or not? Yes. Here it is moving like this, so 2 centimeters. Here it is moving like this, so how much centimeters ma? 8. 8 into 10 raised to minus 2 by 1 into 10 raised to minus 2. So what do you get ma? 8 seconds. Same induced EMF will be same. Here more EMF but time is less. 2.4 for 1 second, 2 seconds 4.8. Here 1 second is introduced 0.6. How many seconds is there? 8. 8 6 are 48. So same voltage will induce, but how much time it will stay? That is important based on the moment of the loop that is present in the presence of magnetic field. So next one is last question. This is very important question for competitive point of view. Also this type of questions will get. Okay, let's see what that question. A 1 meter long metallic rod is rotated with an angular frequency of 400 radians per second about an axis normal to the rod passing through its one end. The other end of the rod is in contact with circular metallic ring. A constant and uniform magnetic field of 0.5 Tesla parallel to axis exists everywhere. Calculate the EMF developed between the center of the ring. So we have a metallic ring rod. What we are doing, for example, this is the rod, means this is the portion. This is the rod attached to some bob. We are rotating ma. of radius 1 meters, and angular speed of this one is how much? 100 radian per second. One end is at the center, one end is contact with circular loop of radius 1 meter that exists uniform magnetic field. What is the length of the rod here? L is equals to 1 meter, right? Angular speed omega is equals to 100 radian per second, and magnetic field that present is what? 0.5 Tesla. Here also the particle is moving in the presence of magnetic field. It induces which EMF? Motional EMF, that is E is equals to what? BLV. Have you seen that? We should consider the potential difference between these two. So we should consider both ends. One end is at rest and the other has some velocity, right? Here one end is rest and the other moving with velocity v. What is the average velocity? V average is equals to 0 plus v by 2, that is equals to what, ma? V by 2. As we know, there is a relation between linear velocity and angular velocity. What is that? V is equals to r omega. Here radius of this loop is equals to what? Length of the rod. So what I can do here? V is equals to L omega by 2. Therefore, induced EMF E is equals to BL into L omega by 2, nothing but half BL square omega. So this is very important condition for inducing EMF when you are rotating the particle in circular path of BR square omega or L square, because as we know, if it is making these motions, L is equals to what, ma? R. So just we all have all the values. What are the values? We have half into B, 0.5 Tesla, length of the rod is 1 square into 100. Is it right? Sorry ma, we consider omega is how much? 400. Omega is what, ma? 400. So here also 400. 1 by 2, so 2 ones are 200. Half 0.5 converted as what? Half into 200. So what do you get? 100 volts. So therefore the EMF induced in this case also what? Induced in this case what, ma? 100 volts. So these are the problems that has been discussed in this chapter. So in the next class I am going to start the new chapter, the very interesting concept that are called alternating currents. Thank you, students.